just for the benefit of people who are a little uncomfortable with these, I thought we'd do an example of, this is actually a personal example, hope you don't mind me getting a little personal here, of a time when I used logarithms in my real life, my actual real life. Check it out. So here's a little story about me, something you may not know about me. I have a genetic disease, a genetic condition called hemochromatosis. This is a condition that affects, it's genetic, right, and it only exists basically among sort of Northern European white people have this genetic condition. And it's a recessive trait, so about 1 in 20 Northern European white people are carriers of the recessive trait but do not have hemochromatosis. In order to have it, you need to inherit the recessive gene from both of your parents. So about 1 in 400 of that population actually have hemochromatosis. And I am one of the chosen few. What it does is, this is something, there's no cure for it really. It ruins the system in your body which removes iron from the blood. So if you have hemochromatosis and you're not being treated, then the amount of iron in your blood is much higher than a typical person. And this can kill you if you let this go on for too long inside of your body. The iron will accumulate in your liver and kidneys, and those organs will stop working. This is sometimes actually diagnosed in people who go to their doctor and their feet are turning orange. That's because the super iron overload has sort of expressed itself as actual rust in your skin. It can happen. Anyway, I have hemochromatosis, and so I have too much iron in my blood. Now it turns out there is not really a medicine for that. There's not an app for that. There aren't drugs which will remove iron from your bloodstream. I'm not sure why. You might want to get to work on that if you're a medical type person. But anyway, right now the only good way to remove iron from your body is to remove blood from your body, because that's where the iron lives. All right. So the treatment, this is referred to as phlebotomy, meaning removal of the blood. Phlebotomy, right? What this is, and this is something that I have to do basically for the rest of my life. I go into the doctor or whatever, and they remove a standard amount of blood. This is like the amount of blood which you would give when you just donate blood somewhere. So it's a pint of blood, which for a person of my size is about, I'm going to say they remove 10% of my blood. This is what it works out to be. A typical person, if you give one of these pint bags of blood, that's about 10% of the blood in your body. And the reason this works is that this is like one of the only medical conditions for which bloodletting actually works. Like they could do this with leeches and it would actually help. Anyway, the reason it works is they take the blood out of your body, they just throw it away, and you will have lost 10% of the iron in your body. And your body can regenerate its own blood, but your body does not regenerate its own iron, because iron is an element. The only way iron gets into your body is you eat it. So they suggest that you try to eat less iron, and then you do this phlebotomy every so often. Every time you do it, it reduces your iron by 10%, and if you do it enough times, you'll get down to acceptable levels. All right. So we're going to do sort of a math problem about this. The obvious question, and the question that everybody asks when they're first diagnosed with hemochromatosis: how many times do I have to do the phlebotomy to get myself back down to the baseline healthy level of iron? All right, and here are the numbers on that. A typical healthy person, a lot of people have problems with not enough iron. This sort of too much iron is a more rare phenomenon. Anyway, a healthy person with a good amount of iron, so healthy iron. And this is measured, the actual thing which they measure this is called the serum ferritin level. I'm just going to say iron, but it's this, if you care, this is actually what they're measuring. A healthy level is 50, and I believe the units are micrograms per liter. This is a very small amount in terms of, you know, holding a block of iron in your hand. 50 micrograms per liter of blood. Oh, sorry, I'm looking at my paper. It's nanograms. Probably don't actually care. It's even smaller, isn't it? Anyway, 50 nanograms of iron per liter. When I was diagnosed with hemochromatosis, when I found out that I had it, and they said, son, you're going to have to do these phlebotomies. They measured my serum ferritin level, and mine was, when I was diagnosed, 650. Way too much, all right? The sort of you're about to die level is like people with orange feet, they're going to read something like 1500. So I was never that high. It's because really you have to live for a long time with this condition in order for it to kill you. If you find out about it when you're fairly young, which I did, it was a few years ago for me, they can do the phlebotomies and get you down to the healthy level, and it doesn't have any other effects as long as you continue to do the phlebotomies. Anyway, what I want to know is how many phlebotomies, I'm going to say phlebs, do I need to get down to 50, right? If I start at 650, how many do I need to do to get down to 50? And this, of course, is what I asked my doctor. And he actually gave me a figure, and it turns out, we'll see, the answer that we're going to get is actually remarkably close to the doctor's, what the doctor told me. So, good job to you, doctor. How are we going to approach this? And you may be wondering at this point, what does this have to do with exponential and logarithmic functions? I hope you don't mind me telling you this. You know, when I was I remember as soon as I was talking to my doctor about this treatment, how the phlebotomy works and all that, I was thinking, man, this is a pain. I'm going to have to do this for the rest of my life. But in the back of my mind, I thought, this is going to be this make a great calculus problem about exponential and logarithmic functions. Tells you a little something about me. Maybe I shouldn't have told you that. Anyway, how do we do this? Well, let's just play around with this a little bit. For instance, what do you think my ferritin level is going to be after the first phlebotomy? That's what I would like to know. So after one phlebotomy, you know what I'm writing here. It'll be, well, let's say I start at 650, right? And then if you take what I said every time you do the phlebotomy, it decreases by 10%, right? That's because they just remove 10% of all of my blood, and assuming the iron is equally distributed, they're going to remove 10% of the iron. So after one phlebotomy, it's going to be 650 minus 10% times 650, right? Because this is how much I started with, and then you take away 10% of that. Well, 10% is, you know, this is the same as 650 minus 0.1 times 650, right? That's what 10% is. What's that? I can do that in my head, right? You just sort of move the decimal point. 65. And then you subtract, and you get 585, right? So after the first phlebotomy, I should, in theory, go from 650 down to 585, all right? Actually, you can do this a little bit cleaner. Rather than doing the 10% and then subtracting whatever, it's totally equivalent to do it in this way. Or, I'm going to get the same answer, but this is just a different way of thinking it through. Rather than saying you start with all 650 and then you remove 10% of it, you could just do this, 650 times 0.9, that is 90%, right? Rather than saying I start with 100% and I take away 10%, you can just say what I started with, I'm going to end up with 90% of that. And if you do this on the calculator, you get this number. All right? So basically, every time, you know, what's going to happen the next time around? Every time you lose 10%, another way of thinking of that is every time what happens is you're going to multiply your figure by 90%. Right? Because every time you do the phlebotomy, you end up with 90% of what you started with before you did that step. All right, so for instance, after 2 phlebotomies, what am I going to have? After 2 phlebotomies, this was after the first time, and then after the second time, it's going to get multiplied by 0.9 again. So it's going to be 585 times 0.9. And I don't really care. I mean, that's just whatever that number is, right? If you want, you can put it into your calculator. Actually, it's not very helpful to write it this way. I'm going to, instead of writing 585, I'm actually going to write it this way, because that is 585, right? So this is really 650 times 0.9 times 0.9, right? The 585 was the 650 times 0.9. And then I multiply by 0.9 again. Another way of writing this is just 650 times 0.9 squared. So after 2 phlebotomies, you get 650 times 0.9 squared. What are you going to get after 3 phlebotomies? Well, can you sort of see a little pattern here? What do you get after 3 phlebotomies? You're going to multiply by 0.9 again. That's going to jack up the power here to 3, right? So it's going to be 650 times 0.9 to the 3, all right? Let's just go for a general formula here. After, say, X phlebotomies, what's my ferritin level going to be? After X times, it's going to be 650 times 0.9 to the X, right? Because every time you do it, it increases the power by 1 more. After 2 times, the power is 2. After 3 times, the power is 3. So after X times, the power is X. All right, we're on our way here. The question, remember, was how many times do I have to do this until the level equals 50, right? The 50 was the healthy level. So the way to set that up as an equation, I want to set up an equation here and then, you know, solve for X. So this is my level after X phlebotomies, and I want that level to go down to 15, and I want to know how many phlebotomies does it take. So how do you set that up? You just do this, right? 650 times 0.9 to the X equals 50. Did I say 15 before? I meant 50. 50 is the healthy level that they want you at, all right? And now, solve for X. No problem, right? Once you have it down to an equation, like that's usually the hard part in the real world, is figuring out what the equation is. And then you just do some math to solve the equation, all right? That's where we're at right now, though. How do we solve this for X? Well, I mean, you want to get X sort of by itself on one side. So the first thing to do would be to divide both sides by 650. It's going to say 0.9 to the X equals 50 over 650. Whatever that is. You can put that in your calculator if you want. Actually, this is, you can simplify the fraction. It's 1 over 13, isn't it? Anyway, 0.9 to the X equals 1 over 13. Now, how are you going to solve for X in this case, all right? Now's the time when you have to sort of pause a little bit and think about your life a little bit. Here's some wrong answers. How do you solve for X in this case? How about, can I like divide this 0.9 onto the other side, and then I'll have just X over here? It's a good idea apart from the word divide. You don't divide in this case, because this is not 0.9 times X. This is 0.9 to the power of X. So what you need to do is some kind of operation which will undo the exponents, all right? Have you ever heard of such an operation? There is such an operation, and that is called the logarithm. That's the whole point of logarithms, all right? So what I'm going to do, you probably know, I hope you know, there's different logarithms, right? There's the natural logarithm. There are also logarithms using other bases or whatever. In this case, I think it's easiest, and there are different ways you can do this. I'm typically going to do it in this way that I'm about to do. I'm going to take the natural log on both sides. So it says natural log 0.9 to the X equals natural log 1 over 13. All right. What is the ln? It's a function. All right. And there's a button on your calculator that says ln. What's the point of? So actually, this side you can actually put that in your calculator and get the number if you really want to know what that number is. Anyway, what was the point of doing this step? It's that the natural log has a very nice property. This is something that you definitely should know about the natural log. And this is it. This is actually not special about the natural log. This is true of all logarithms. The log of a to the power b is equal to b times the log of a. All right? When you have an exponent on the inside of a logarithm, it can come down as a multiplied coefficient. And that's what I'm going to do right here. it will say x times ln of 0.9 equals ln of 1 over 13. All right? Wasn't that awesome? This is kind of the whole point of logarithms. If you're the kind of person who feels nervous about logarithms, in this sense, the logarithm is just a thing that you can do which will move the variable out of the exponent. And now you can solve for the variable, no problem, right? This is actually x times something, so you can divide this over, and that will solve for x. So it is ln of 1 over 13 divided by ln of 0.9, all right? And that's a thing that you can do on your calculator, right? You have a ln button on your calculator. So just type this into your calculator, which I did. I'll tell you what I got. I got 24.34, all right? So this is about 24 or 25 times you're going to have to do this phlebotomy thing before it gets your level down to 50. How do you like that? I'll tell you what my doctor told me. I said, how many times do I have to do this? He says, you'll probably have to do this about once every 2 weeks for a year, all right? And if you think about it, that's about this number, right? If a year is 52 weeks. Once every 2 weeks for a year. And that's what I ended up doing, and it took me a little bit longer just because I didn't actually do it every 2 weeks, but that's how we do it. Anyway, logarithms, all right, gets the job done. Whenever you need to solve for x and the x is inside of the exponent, that's when you use logarithms, and it really works.